the speaking program begins after lunch, but I thought I ought to say a word about the packages you find on your chairs or found on your chairs. Instead of the usual program booklet published in association with the dedication of a new building, we published a box. Okay? Some who've seen the building will recognize a certain similarity in shape and design to the building itself, a design inspired by artist Kenneth Nolan's color treatment of the walls. This box and its contents are sign and symbol of the building and of its occupants. We hope you will enjoy this contemporary time capsule. Doc Edgerton buried one last night. We have produced one this morning. In the box, you'll find brochures and artifacts produced by and describing the activities of the three major programs in that building: the Media Laboratory, the Council for the Arts at MIT, and the Albert and Vera List Visual Arts Center, whose programs are overseen by the Committee on Visual Arts and its staff. In the box, there is a feast for both eyes and ears. I should say also that there is this book, which describes the artist-architect collaboration that was involved in the building. It will fit in the box, but you won't find it in the box yet. It's at the reception this afternoon, and I urge you to pick up a copy this afternoon at the reception. So please enjoy the box. Please enjoy your lunch, not in a box. But we are pressed by the program for the rest of the afternoon and late afternoon, and it seems a good moment to begin. We come together today for a remarkable occasion. The building we are dedicating this afternoon is extraordinary, both in concept and in execution. The people who are working in this building are likewise exceptional. A cast of energetic, creative visionaries drawn from disparate fields of art and science to pursue a common purpose. That purpose is, fundamentally, the advancement of the art, the quality, and the depth of human communications. And the people for whom we named the building this afternoon, Jerry and Leah Wiesner, are equally special. In their wisdom, in their vision, in their caring for MIT, and for how this institution and its people can contribute to a better world. I can think of no more appropriate way to mark the important place that Jerry and Leah hold in the life of MIT and to reflect their 40-year commitment to the fields of art, of the arts and communication than to name this building in their honor. May I take just a moment, however, to draw your attention to still another remarkable assembly. Those individuals and corporations and foundations, nearly 100 of them in all, who have entered into partnership with the Institute to create a vital new facility to house programs in arts and media technology. We are most grateful for their gifts, not only of building funds, of program support and equipment, but equally for gifts of foresight and intellect. Because of their generous support of a shared vision, we have today on our East Campus a window into the future. We will be saying a bit more about the individual donors later in the day. I would like to say a few words here about our corporate and foundation benefactors. They come from fields of interest seemingly distant from each other, and they represent a truly remarkable melding of industrial and philanthropic endorsement of this new and exciting venture. The companies, for the most part, are new friends to the Institute. They are partners in areas of research characterized by the intersection of print, video, and computer media. These industrial sponsors see their future as partly or largely vested in the creative use of new technologies for human communication. I wish we had time at this point to ask each of the corporate representatives to stand for our recognition, but we will be paying tribute to them at the ceremonies in the Wiesner building later in the day. I should tell you, though, that these corporate donors range from giants in television broadcasting and newspaper and magazine publishing to many of the world's most prominent electronics companies, from pioneers in photography and film and video to leaders in acoustics and sound systems, from foundations whose grants and gifts most commonly support laboratory research in science and engineering to foundations who are most often associated with support of the fine arts. I would like to take this occasion, however, to single out just two of these notable institutions. The first is a major industrial donor, the NEC Corporation of Japan, whose generosity allowed us to conclude this project. You will hear from the NEC chairman, Dr. Koji Kobayashi, during our afternoon symposium. His corporate philosophy on computers and communications is in clear harmony with our vision of media technology, and we are most grateful for that communion. The other institutional donor I want to mention came in right at the beginning of the project. The National Endowment for the Arts provided early and welcome support in the form of a major grant in support of the pioneering experiment among architect I.M. Pei and artists Scott Burton, Richard Fleischner, and Kenneth Noland in the design of the building. We are extremely grateful for that early vote of confidence in an experimental collaboration that has produced such stunning results. And I'm delighted that we have with us today a representative of that agency. He is Mr. Hugh Southern, Deputy Chairman of the National Endowment for the Arts. He has agreed to say a few words on behalf of the agency and on behalf of its chairman, Mr. Frank S.M. Hodsell. Mr. Southern.
Good afternoon. I'm first of all bring greetings from Frank Hodsell, who was scheduled to be here originally and unfortunately at the last moment couldn't make it. But for me that's a very great pleasure since it meant that I got to make this visit instead. I want to first of all thank David Saxon, Chairman of the MIT Corporation, Paul Gray, the President, John Deutsch, the Provost, and Jean de Monceau, Dean of the School of Architecture and Planning, for giving me and the agency this opportunity. I'm delighted to assist in dedicating this magnificent building designed by one of the 20th century's greatest architects, I.M. Pei, and we at the endowment had the great honor of his being a member of the National Council for many years. As you can see, this is going to be throughout a tribute to one or another kind of collaboration. I think it's fitting, too, that the building is named for Jerome and Leah Wiesner, great figures at MIT for many years and also important figures and significant contributors to many aspects of our national life. Dr. Wiesner set an example of public service in so many different arenas that I would spend the rest of the afternoon if I recounted them. Among them as a science advisor to President Kennedy, and we believe too that he's done as much as anyone to make MIT one of the great institutions of its kind, not only in the United States but in the world. The building will be a tribute to him and also, I think, a testament to his leadership for a long time to come. We're delighted, too, that the National Endowment, through a 1979 challenge grant, had a role in the building's creation, and also that in 1980, the Art in Public Places grant, referred to just now, assisted in a highly successful artist-architect collaboration, integrating works of Kenneth Nolan, Richard Fleischner, and Scott Burton into the overall design of I.M. Pei. It's nice when one thinks of macro grants like challenge grants and what they can do to make a building project come to life, but it's even, I think, more satisfying to us to recall a very modest grant that led to such a magnificent outcome. The building and the programming that it will contain is important to our agency for many reasons. First, it's an outstanding example of public and private partnership in the artistic creation. It's an exemplary piece of architecture and design. We think that the issue of collaboration between artists and architects is an issue that is very much alive, and that this may be a forerunner of many further such collaborations. Within the building, the Hayden and List galleries are themselves wonderful spaces for the exhibition of art. We're glad to pay tribute in that connection to Kathy Holbrook, the director, who's highly regarded in our halls and most helpful to us too. She is now on the overview panel of the Visual Arts program. And finally, we think that the List Center represents a wonderful example of public access to the best in contemporary art. The Media Lab is a major center for the pioneering in new and complex relationships between arts and media technology. I think that one of the things that artists and scientists have in common is that the underlying method is that of trial and error. And to see those conceptually united in a building where the work that will be done will be open-ended, will be exploratory, will be speculative, reflects the bringing together of the most creative elements of both worlds. The building is now part of a growing international network of academic centers exploring media and arts technology. The Institut de Recherche et Coordination Acoustique, the music at the Centre Boberg in Paris, the Center for Computer Studies in Music at Stanford University and in other places in the world. And this facility, so far as the endowment is concerned, though some of you might judge this to be more an example of MIT's creative grantsmanship than of the actual interests of our agency, I think I'd like to correct that and say that one of the reasons why MIT's applications to us are very frequently successful is because we enormously respect both the artistry and professionalism of proposals that are made to us, and that view has been shared by many of our panels over a long period of time. I'm confident that it will continue to be so in the future. Our museum program has supported the permanent collection and new exhibitions. It has also dealt with some issues of museum technology. Our visual arts program has dealt with exhibition space for innovative contemporary artists. It's supported graphics projects. The interarts program has dealt with interdisciplinary experimentation, performance art, and other genres. The media arts with film and video making, especially with those concerned with new technologies, such as spatial imaging. The design arts program has treated this as a model situation for design competition. Literature has, with you, explored the possibilities for electronic publishing. Music has supported projects dealing with computer-based experimental music, and art and education has been involved with community resource projects generated out of MIT. As you can see, the diversity, the richness, the texture, the intense investigation, the inquiry, the intellectual curiosity that this range represents is something that I think brings our agency and MIT very close together. Finally, I want to say a word about the future. I think that art has a place in ameliorating what was referred to briefly this morning, the possibility for alienation in society. I think that art and science together are likely to be more humane science and less self-centered art. And I think that the future collaboration that this building and the people and the ideas and the inventions that it will house are an immensely hopeful signal for this campus, for this city, and indeed for the entire nation. Thank you very much.
Thank you very much, Mr. Southern. Now it is with particular pleasure and respect that I introduce to you a man who already occupies a place in the pantheon of MIT's great figures. He is our former president and former chairman of the corporation, a man whose own vision of MIT's special role in transcending the several cultures is brought closer by the building we dedicate today. He is Dr. James R. Killian, Jr., who will introduce another of our luncheon speakers. Jim?
President Gray, ladies and gentlemen, for an old hand who's been around for a couple of 100 years, this is certainly a joyous occasion. Knowing as I do all the great efforts and planning and dreams that brought us to this place today. It is joyous, too, because I count it a privilege to say a few words, a quite personal word or two about our speaker today. For 40 years, we have been friends and colleagues at MIT, and a quarter of a century ago in the corridors of power in Washington. It all started this way. In putting my files and papers together for transfer to the MIT archives, I found a long-forgotten letter I wrote in 1945 to a Mr. Wiesner, a young engineer on the staff of MIT's wartime radiation laboratory. In part, this letter said the following: Dear Mr. Wiesner, I wish to confirm the offer which Professor Hazen has discussed with you, a position in our Department of Electrical Engineering. We take pleasure in inviting you to join the Institute staff as an assistant professor for 3 years. And then this came the important part. We look forward with much pleasure to having you join us at the Institute. We believe that opportunities over the coming years in your field will be of ample scope to your work. I hardly knew in 1945 how happily prophetic my letter actually was. But here we are today, this great gathering assembled to celebrate the accomplishments of Mr. Wiesner, whom I addressed, trying to lure him to MIT. It is a great good fortune for science, for technology, for the arts, for MIT, that this young engineer said yes. My personal and collegial relationships that was to bring the two of us together as colleagues at MIT occurred, as you heard just a minute ago, in Washington, when we both served on the staff of presidents. I as science advisor to President Eisenhower, and Dr. Wiesner following as science advisor to President Kennedy. I think it of interest that we had interdisciplinary relationships in the politics of those days, because Dr. Wiesner served on the Eisenhower Science Advisory Committee, and I occasionally did a job for him on President Kennedy's committee. So there were no political barriers between the scientists who served the presidents in those days. These experiences in the domain of presidential advice were pioneering experiences that contributed importantly to our own self-development and to our affection for each other and our sense of mutual national goals. It was not long after he joined the faculty of the Institute that Dr. Wiesner was appointed director of the Research Laboratory of Electronics, a successor to the big wartime radar laboratory which had recruited him from the Library of Congress. This was the first of the great interdisciplinary laboratories established by the Institute, and he set a pattern for our new policies concerning the conduct of research and learning. During Dr. Wiesner's leadership, he brought to this laboratory an interdisciplinary congeniality that attracted not only artists and other creative talents, but a truly extraordinary array of philosophers, linguists, artists, communication specialists, linguists, and whatnot, that found this laboratory a stimulating place to have contact with and in which to work. Out of the resonance prompted by Norbert Wiener, the great mathematician's brilliant mathematics, and the inspiration Wiesner gained from it, came a new sense, a deeper sense of human communications that invigorated our programs in engineering, the neurosciences, psychology, linguistics, computation technologies, and the arts. Dr. Wiesner moved rapidly, of course, from the RLE experience to important administrative posts at the Institute, and finally, as we all know, to the presidency, a position which he filled with extraordinary acclaimed brilliance. This was the period when MIT was emerging as a great research center, holding a place among the institutions in the forefront of the world's great research universities. These responsibilities, much needed resources, particular resources to establish new programs to achieve new integrations among the arts and technology, the social sciences and the sciences. Clearly, he understood what Professor Thomas Kuhn of our philosophy department meant when he said, "We have only begun to discover the benefit of seeing science and art as one." This sense of kinship was once long ago eloquently stated by William James, the great philosopher, in his oft-quoted statement that the ideal is the union of the mathematician with the poet, fervor with measure, passion with correctness. And we've seen that ideal permeate this institution. Our accolade today for Dr. and Mrs. Wiesner is an expression of our understanding of how great has been their influence and how major their efforts to achieve what I can rightly call an awe-inspiring advancement in the way this institution is moving toward the university of the future. It is hard for me to speak about Dr. Wiesner in factual terms because our friendship and our sense of allegiance to all the great purposes of the Institute and of learning has been so close and so long sustained. He is a friend and colleague I cherish beyond measure, and I count myself among those who greatly admire his partner. Leo Wiesner has shared his life and his ideas and ideals and efforts in an extraordinary way. In the Old Testament book of Amos, the question is asked, can two walk together except they be agreed? Clearly, Jerry and Leah have walked together in full agreement in the service of this institution and in the developments bringing us together today. Thus, in introducing Dr. Wiesner, I emphasize how eminently suitable it is that the glories of our new arts and media technology bear the names of both. With these feelings of affection, I present Dr. Jerome B. Wiesner, fully aware that those who love him call him Jerry. He will speak on creating with computing. Dr. Wiesner.
Thank you, Jim. This day and the events yesterday keep reminding me of a television program called This Is Your Life. And I keep wanting to correct the exaggerations that go by, but I'll do that another time. There are a couple things I would like to say, though. You don't know how important Leah was to my existence at MIT. I was working in Washington for Archibald MacLeish and quite happy or unhappy, alternately, in the job. The war had begun, and I was feeling that what I was doing, even though it was helping to set up the Office of Facts and Figures, which was going to be our propaganda agency for the war, was not really quite a technical challenge. All I was doing is signing requisitions to RCA for equipment, and I figured somebody else could do that because you either bought their equipment or you didn't get anything, so you didn't have much choice. But I got a letter from Sam Gouge-Schmidt, who had been a professor of mine at Michigan, I think encouraged by Louis Smullen, who had been a graduate student colleague, inviting me to come to the radiation lab. And I wrote a letter saying I would love to do it, but I was extraordinarily busy. I didn't write it, I dictated it, fortunately, so it didn't go out. And I went home that night and told Leah about this, and she looked at me with that scowl she can get when she knows what I'm doing is foolish. And she said, I thought you wanted to get back to something a lot more technical. And I said, yes. And I went back in the morning and I tore up that letter and I wrote a letter to Sam saying I'd love to come. And I came. And that's the way one's life gets changed when you have somebody sensible around you all the time. The title of my speech, Creating with Computing, started out as Thinking with Computing, as suggested by the program managers. I thought maybe creating was a more interesting and easier subject to deal with. I must say I've learned that you can't really deal with either, but I will deal with it. As I've gone through various drafts of this paper, I have done it on computer, and then young ladies in my office have tried to make English out of it and edit it. And each time we've gone through a cycle, they've given it a new name so that we could tell one from the other. And this was put in my briefcase last night, and on the disc was the title, Let's Hope. And so I suspect that's not a bad idea for all of us. The title, Creating with Computing, obviously raises an infinity of questions, such as who created what and why, and even what is meant by the word creating. And if I had another hour, I'd tell you about my dictionary research on that simple word, as we heard on some other words this morning and yesterday. Well, there's no simple answer to these questions because they apply to so many different people, each with its own or her own idiosyncratic ways of working and thinking, and specific styles and activities that range from the most ingenious, untutored craftsmen who think in terms of the world in which they've been brought up, and inventors, to all manner of scientists and engineers who think in very specialized worlds. A chemist, for example, who's inventive, lives in the world of chemicals and symbols and spinning atoms, and he creates in that world, and writers and filmmakers and scholars and just plain human beings. It's quite accurate, though, I suppose, and if an existentialist escape to say that together we are indeed creating the future. Sociologists, who I often think are wrong, say that we are living through a second industrial revolution propelled by communications and computers and control systems, basically an information revolution in which in the first industrial revolution, humans expanded their physical capacities, that is, multiplied their muscle power by creating machines that harnessed energy extracted from nature, found in waterfalls and fossil fuels, and now in the atomic core to do much of society's work and to expand vastly their mobility. And the result of that has been a liberation from drudgery and poverty through an increase in individual productivity. I don't like the word revolution because it was more of an evolution over a very long time, and I think we're engaged in a second evolutionary cycle. And when people say revolution, they expect everything to happen fast and even to be right. And I think we're far from having exhausted the capabilities of this new information communications revolution. And in fact, I think the most imaginary things we can say will turn out to be fall far short of what is probably possible. If Tom Watson was here today and he couldn't come, I would tell you about his prediction in 1947 that the world could probably absorb 5 computers. But since he's not here, I won't tell you about it. Today's symposium is examining one facet of that second industrial revolution or evolution. We're leaving out in our discussions such things as robots and bookkeeping machines and a lot of other things which have become so vastly important to our society. And we're going to concentrate, the symposium is concentrating, and I am concentrating on how we can enhance human creative abilities. And like the Media Laboratory itself, today's symposium is intended to explore the scope and potential of the emerging areas of information technology, broadly speaking, communications and computing. And because Walter Rosenbluth told you about our serendipitous interaction with Norbert Wiener at the end of World War II, I will save a little time and not do that. But our eyes were opened by Norbert, maybe too far. I began to see the whole world as a communication process, even an electron talking to the proton. It's, after all, communicating something. And when I worked, it was a bad thing for me when I worked in Washington, because I see now, I believe all social processes are communication processes. And one day President Kennedy said to me, "Why were you smiling so while we were talking about that terrible disaster we're dealing with?" And I said, "I didn't realize I was smiling." And he said, "What were you thinking about?" And I said, "Well," I told him my view that individuals, societies, cells we're now learning, are all communicating devices. And if, as Norbert Wiener said, if it wasn't for communications and information, life itself could not exist. And I guess I was dreaming about how we were dealing with an information process that we should have dealt with 2 years ago. How the feedback cycle had been so long that the government was now trying to contend with a problem that it was impossible to solve, and we just had to live with the disaster that, a little bit like South Africa, that we had not been perceptive enough to catch early enough to do anything about. And I think that's the nature of our society, and as it's become more complex, as the scale has grown, as transportation and information have shrunk, The world is struggling to somehow learn how to keep the excursions down. Mr. Southern used a word which is a perfect description of what we hope we're creating, a place where experimentation can occur involving men and machines, and certainly in the arts, but we hope in many other fields like learning too, and maybe we can even help in our efforts to improve the human-machine interrelation, everyone who uses computers. But I regard the Wiesner images have made me believe that all of life, all of society, is an experimental learning process. And I wish the politicians would learn that lesson, because they either believe when they start out to do something that they have the answer, or if they don't believe it, they feel they have to make believe they have it, which means that things can go very badly wrong before they are willing to perceive an error and make a correction. Whereas in science, we're mostly used to having our experiments come off in a different direction than we intended. Often we learn something, and we get our credit or discredit not for having made a bad mistake, but for being the first to perceive it. If you're the last who is willing to admit that what you're doing is wrong, you pretty fast lose your reputation as a scientist. But if you're willing to be among the first to recognize what's going on, then you don't have a problem. The Media Laboratory is a product of the MIT culture. And I must say, if I can go back to Jim Killian's introduction, that it is the MIT culture and not individuals that is the important thing. MIT is a place where anybody who makes a modicum of sense can do anything he pleases, almost. He has to meet an occasional class, and he shouldn't overrun his budgets too far. But it's a very encouraging, very enriching, very permissive environment. And my only goal as president, aside from raising money, which is a natural responsibility of a president, was to be an enthusiasm amplifier and hope that people had the opportunities to do the things they want to do, because I believe so completely that the experimental approach, governed with a little common sense and maybe even a little theory, is the only way civilization makes progress. And the Media Lab is a place where creative and curious people are exploring uses of electronic media. Now, the laboratory is a direct consequence of the establishment of the Council for the Arts by alumni and friends. I said written slightly more than a decade ago. Last night somebody said it was 14 years ago, to nourish the arts at MIT. And at its initial meeting, two distinguished poets, Stanley Kuznets and Archibald MacLeish, challenged us to see science and the arts as a part of a total human experience. There was, Stanley Kuznets said, many disciplines, but only one imagination. And that statement has continued to resonate in my head as we've talked about what we were doing in the laboratory, as we talk about educational reform, as we talk about what the goal of a good education is. What he was saying is the head can store many different kinds of information, but somehow it has only one process for bringing it all together. And to me, that meant the more you have, the more different things you have in your head, the more you understand all of the totality of life's experiences, the greater chance you have of being a truly creative and contributing citizen. Archibald MacLeish pushed us further, and he argued that humanity could only be saved by bringing science and the arts together again. And that's a pretty tall order. He was obviously looking back to the 19th century humanist scientist who was able to encompass all that was known. And we'll have to do a lot of abstracting, maybe Media Lab can help do that in order to meet that goal. The electronic information revolution started kind of innocently with the invention of the telegraph and the telephone, followed by the wireless and then picture transmission devices, including television. These systems have provided humans with global communication capabilities. Some people may want to challenge the positive influence of all that. But these were all passive devices, primarily able to get an image or a voice or a message from one place to another to extend the range of the human senses. The electronic computer brought something very different, and some people recognized it very early. With its symbol manipulation capability, it provides a means to expand mental powers and to do many routine mental tasks. And it's why I think we are indeed experiencing the second industrial revolution. Without that active participation, active ability to manipulate, to store, to find information, we would be in a very different stage in the electrical communication business. We are just at its beginning of this evolutionary period, and face the challenge of developing much more effective systems and also of adapting to the many opportunities, changes, and problems that this will leave in its wake. One of the aspects of information and computing developments which are particularly intriguing to me, possibly because of Norbert Wiener's interests and the way we structured the research laboratory of electronics, is that many of the technical developments mimic living systems, so that in a sense we are retracing nature's invention of information and control system, but with some differences. Maybe one shouldn't be surprised that we are mimicking living systems, because they're the only systems that we know. Now, some people will be offended by what I'm going to say, but I think man-made systems use better components. Electrical signals travel 1 million times faster than signals on nerve fibers, and semiconductor devices also act billions of times faster than neurons, which are the biological information processing elements. Also, man-made elements appear to be more reliable. But nature has a very large edge, maybe a decisive edge, in design complexity involving a number of individual elements it can use in a system effectively. And these are advantages man may never match. Nature may always retain this edge. Who knows? But for the moment, it really doesn't matter. The man-made systems that we're involved with enhance human creative capacities. That's what they can do. But so far, they cannot displace them. Cognitive and computer scientists are having an exciting time trying to understand and imitate human reasoning with computing systems. And though they can do a few things that would be regarded as thinking if done by a human, they differ violently among themselves on whether or not machines with human thinking and creative abilities are possible. Even a so-called artificial intelligence field, which prompted Walter Rosenbluth to say he preferred natural stupidity. His greatest achievement in this field is capturing knowledge and skills of human experts. No matter what one believes about the future, it's perfectly clear that such machines, thinking machines, creative machines, do not exist now. So I think I'm on safe ground if I say at the moment that neither the process of thinking or the act of creation is really understood. So I can simplify this discussion, fortunately, because I'm probably running out of time, by eliminating any attempt to explore either the act of creation itself or machines that can think, and limit myself to the many ways in which the combination of computing and communication as we know it now and can expect it to evolve during the decades ahead will expand the human creative capacity. The rapidly developing computer and information sciences pervade almost every discipline of study in one or two ways, and sometimes both, through the use of data and information processing machines to facilitate the study of a problem, or through the concepts, and I think this is very important, concepts of information and computing that help people to understand many previously puzzling phenomena. Examples of this can be seen in biology, in the social sciences, in the study of languages and cognition, and to a degree not fully appreciated in the study of computing and information processes themselves. And as this work continues, there is being created a new scientific discipline focused on the study of communications, information processing, and cognitive processes. Now, we all know that the word computing does not describe what a modern information processing machine can do. Computing calls to mind number crunching. In fact, the goodness of a computer, and there's that word again, computer, is generally measured by the number of millions of arithmetic operations it can perform a second, even if it is being used for the composition of music, or to help an astronomer find a black hole in a cosmic haystack, or to assist a physician in seeing a picture of the brain, or help an electrical engineer to make a better information switching system. Arthur Koestler, in his book, The Act of Creation, argues quite convincingly that novel creations of the mind require the intersection of two normally unrelated sets of ideas or mental fields. And that's why he says most creative products, from puns and bad jokes to the most enjoyable music, art, or scientific discovery, or even engineering design, contain an element that they all have in common. They all give an element of joy when they are experienced or beheld. And what I believe the role of the machine, role of our laboratory in a sense, is to increase the size of the mental fields available to an individual and to increase the probability that the searching human mind will provide productive, or will find productive intersections. In fact, Sherry Turkle this morning expanded my vision of the problem. We have a mismatched input and output system. The visual system takes in information at a fantastic rate, and when we try to put it down, we use this particular part of the human system that wasn't designed for rapid transmission of information. It gets very tired if you use it very long or try to put, if you took the whole field of one television picture and tried to write it out, you would have a sore arm. And so, in a sense, we're trying to contend with that mismatch in which the human creative mind, in fact, can't get information, can't ask questions fast enough, can't output fast enough. And Koestler's insight to the creative process is supported by an examination of creativity in many areas, and in particular, the artist's dependence upon familiar themes. I hope I don't offend all the artists present. Most novels, I believe, have an element of autobiography, or at least biography. Artists have styles that they find hard to leave behind, that is, essentially transfer functions that are their signatures. Scientists tend to use the same techniques and approaches that were successful on earlier problems, even when the new ones are very different and their trials continue to fail. It should be clear, I think, why I avoided any attempt to explore the act of creation itself or machines that can think, and just explore the ways in which the combination of computing and communications as we know it now and expect it to evolve can so vastly expand the human creative capacity. I think computing can aid the creative process in several distinct ways, and in order for you to have an afternoon meeting, I'm going to list the ways and ask you to accept this and think of your own examples and not read mine. But my first is by vastly expanding the scope of traditional creative activities by making possible calculations that far, far exceed unaided human capacity, as well as facilitating other traditional tasks such as searching indexes, storing and retrieving large files, and so on. We all know, anyone as old as me can remember the computing rooms full of faculty wives who were turning cranks on programs that were monitored by the scientist who was trying, or engineer who was trying to get some numbers out of his experiments or calculations. And that really limited the scope of scientific inquiry, of engineering design, and that limitation has almost disappeared. The fact is that the human mind can always find a problem that's bigger than the tools we have available, and I'm sure the computer manufacturers love that. But the fact is that very few real scientific analysis or engineering design problems are now limited by computing power. The second way I've already alluded to, and that is by providing new cognitive tools, new models for thinking about problems that involve information, such as understanding speech or the genetic code or the thinking and creating processes themselves, and many others, the economic models that we hear so much about and don't know how to interpret. This provides a basis for thinking about problems in which symbols and their relationships and their identity, rather than the physical properties of systems, are significant. And finally, by providing wholly new media and techniques to be used in the creative process. And this category includes many of the electronic systems that allow new forms of design, music making, modeling of both physical and information systems, and many of the different uses of computing that were explored this morning. And I think with that thought, namely, that we have an open-ended future, that the computer gives us these opportunities and challenges us to understand how to use it more effectively in augmenting the human creative power, I will stop and go hear what others have to say. Thank you very much.